So this week is the week 5 actually, right? Already. So kind of quick. So let's see the last week homework first. Take your week, excuse me, take your homework out. Let's check homework first. Firstly, let's see, what did we learn from last week? Last week we learned the inequality, right? Let's quickly review inequality. Inequality, just like say AX greater than B, right? We talked about these kinds of course, this one could be something like say less than or less than equals or greater equals or not equals, right? So when they both sides came plus the same number, right? Same number or minus the same number, yeah, this one not changing, right? And both sides times a number, and let me change, say D, change a number, right? If the D is greater than 0, it's a positive number, this one not changing, right? So when the D was a negative number, this alligator mouse need to change from greater change to their opposite, right? When the D is a negative number, right? We talked about this one. And of course, the divide, say divide a number, time a number, the same thing can say divide a number, right? Divide number, if their number is positive there, this alligator mouse was not changing. When they time just like divide a negative number, the same, this alligator mouse from greater became negative. I mean less than, just means change the inequality to their opposite direction. So if their initially is greater, you need change to less than. If initially is greater or equal, change less than or equals. Right? So this is the basic information which talked about last week. Right. So let's see here homework part. So homework part actually just try to review this part, right? So let's see here, number 11. So you can see we want to get a solution, say we want to get a solution of this one. So both sides, we can use these rules, right? Both sides divide 2. 2 is greater than 0, it's a positive number, right? So it's not changing. So this alligator mark not changing. So will it be transformed into x, because 2x divided 2 became x, right? So alligator mask was not changing. So negative 6 over 2 divided 2 is negative 3. That's it. So you can graphing. You say ask you graphing this one. So graphing you can do like this way, right? So graphing, when we do graphing, we make sure you guys always know this is the positive, this is the negative, and we also needed to know what's the origin solution, origin start it is, right? By 0. So we say x less than negative 3, so you need to draw different kinds of unit, negative 3. Less than, it means right side, left side, sorry. And they are not equal, right? So not equal, we use the circle, we not use the filled circle, we use the non-filled circle. And less is the left part of this one. So we can graph it like this. If we want to how to write the interval means you can see, notice so here is negative 2 and negative 3. So we can write is negative infinity to negative 3. And this one is not including, we use the parentheses, right? Parentheses, right? When we say including, we use the bracket, right? So this is the answer for this one. So I will talk a little bit quicker, right? Yeah, what is similar situation? So both sides divide 3 for the number 12 here. Both sides is, let me clear this one first. Do I need me? Did you guys make notes here? Yeah, if you make notes, I will clear, erase it. If not, I'll just keep it for a little while. All right, so this one I will be right like here. So both sides divide 3, so left part became x, right? The greater, because of 3 is a positive number, so we don't change. They're the same. So when we go graphing, do the same, right? -3, 1, 2, 3. Here is not including, right? Greater means right part, positive infinity. So we need to write -3 first, right? And parentheses because I'm not including, and positive infinity. So answer is this one. When we do graphing, is this one, and you do an interval notation, so it will be like this one, right? So anyone understand what we talking here? Did anyone understand what are we talking? Any questions?
No.
Questions? Okay, no questions, right? If you have questions, raise your hand, all right? All right. So I will clear off there and we go to number 13. So we go number 13. Number 13, we use the same, use the get solution part. So both sides +2, right? +2. The objective is, make this one back in 0. So both sides +2. So you can get x greater or equal -5, right? So when you do graphing, yeah, we say, I think -5 here, -2.5, -5 is right here, greater or equal. So this time we need to fill this hole, right? And greater means x greater than some number. It means on the right part of this number, right? So when you write the interval notation will be -5 to positive infinity. Positive infinity is this end. Negative infinity is right here. All right, so here you need to change bracket, left bracket, right? Left bracket, so you got like this one, right? All right, so the 14 is the same, both sides -4. So you can say x less than equal -3, right? So when you do graphing here, 0, -1, -2, -3, positive infinity this side, and negative infinity this side. Less than or equal, so you needed to fill this hole, right? And less than means this is the biggest, so only left part. So when you write internal word notation, is negative infinity and -3. It's including we need a bracket, right? Don't use the parentheses, right parentheses, right bracket. Okay, all right. So do the same for the number. Do the number 15. Number 15, both sides. So number 15, I write here. Let me give one more space here. So both sides actually right now is divide -8. -8. Sorry, -8. So what means? Means a -8 is less than negative number, right? So this alligator must from less than or equal change into greater or equal, right? Change directions. So after that, so everything will be the same. So here is negative thing over over 8.
I have a question.
What's your question?
So about those symbols that looks like bones beside some numbers, what do they exactly mean again?
Beside numbers? What do you mean beside
The
numbers?
special symbols beside some numbers. What does it mean?
What are you talking about? Can you say one more thing? I'm not sure. What are you talking about?
Like for example, the special symbol beside 13 and 15. What do they mean?
Ah, this one actually here is come from the book. Actually, I didn't take this off. Actually, see example 225, 224, something like that. Actually, this, you can see this is a page number. I get these kinds of information from a book. And this is the part after the book. After in the back side of the book, describe the practice part. So you don't need to care about this one right now, all right? Because of this one is the examples, I bring it up to talk during our class. Right? Last classes, I say example 1, example 2, example 3. Actually, some of them is from here. Okay. All right. So I gotta understand here. So like something like this one, you don't need to care about this one. This one is actually, this is from the book, so we got it. If you don't really understand, they ask you go back to check the examples, right? So when we do graphing, so the same here, right? So this is positive infinity, this is negative infinity, and 0, and -1, -2, all right? -1, -2. So this one is including -2, right? Field greater or equal this part, right? So when you write interval, so here make sure you write smaller first, right? Small in the left, and use the right bracket, left bracket, and in positive infinity. So that's it. That's it. So, all right, let's see number 16. 16. Here you can see the coefficient of this one also negative as well, -5. So when you do the -5, both sides do the same. So this one will be changed to greater. So greater. So what the left part? Left part change into x, right? Greater than -4. Right? So when you do the graphing, so positive infinity, less negative infinity, 0, -1, -2, -3, -3, -4. All right. So you can mark every unit as well here. So x greater than -4, greater than here. So it means this part. So you can just write, say, -4. Here I didn't say greater or equal, so we use the less not equal, so we only used left parentheses. All right, so here positive infinity. All right, so this is the first part. Second part is one more step here. All right, let me go. Let's see the second part. Let's see the numbers 17 now. 17. So you can see here is two more steps, actually more step, right? So let's see here. So we can see actually they are more complex. Earlier just one step, so you can get the answers already. Here is two steps. The two steps means you need to move all the unknowns in the one side, or write a constant in the another side. Okay. So what do we do here? What we do is we minus 2x, minus to make this one become minus 2x, okay? So we got the right part have no variable, right? Plus 5. So what you can got here? So left part got an x, right? Because so here became 0, here became 0. And so we combine like terms. That's why we earlier learned combine like terms. So greater than, what's the rest? The rest here is -3. See, we only one step, we already got result. So of course you can graphing, all right. I believe we can graphing. Let me write the interval. So -3, this is left parenthesis and positive infinity. So you graph by yourself, all right? I didn't do it right here. All right, do the same here for the number 18. Both side minus plus ax, right? Both side -3. So left part became x, right? Because here became 0, here became 0, right? The left combined like terms. Greater or equals than 7, right? So we can just get left bracket, positive infinity. Same here, 19. So we practice this one, just make sure you guys really understanding, all right? So plus 2x. Actually, wrong. No, I'm sorry, not plus 2x. Here, actually, you can combine first. Actually, became 3x, right? You can do first step, 3x then minus 3x. So here, I need to change to minus 3x. And plus 1, and plus 1, okay? So here, what will be changed? Minus 3x here became x, right? So here became 0, and here became 0. And say less than equal 1. That's it. So remind you here, just let's say here is negative infinity to positive 1. So here is the right bracket. Right bracket is including 1, right? Same here. So this one we need to combine first. This is like term, right? So here became 6x. Both sides minus 6x, and minus 3, right? So the left is became into x, right part became -3. So here it means negative infinity to -3, and use the right parentheses. Check your homework. Did you do the same or different? What I'm talking. Is it easy? Everyone? Nobody answer me. Hey, someone make noise, please. Make sure I actually talk to someone.
Yeah.
Hi.
It's easy, but it takes a lot of steps.
Just not like on top to myself. Good, very good. So it's super easy, right? So after we're talking this one, it's super easy, right? All right, let's move on. All right, so I will pick maybe 2 or 3. I just pick the odd number one to talk, okay? I don't like to talk all of them. All right, so let's see this one. Still do the same similar. So the only thing is here, so you needed to, we add more information here. We need to distribute inside. So distribute inside, everyone can do this one, right? It could be. So after distribute inside, you can do the same as from the 7 to 9 doing, right? So you can say both side minus 3x, both side plus 7. Why we plus 7? Right? So we make this disappear. Here is make this disappear. So the left became 2x, right? Negative 2x actually. Less than or equal, this became 10. So up to now, we needed to, you can see here, it's a -2. So we need to divide -2, divide -2. Well, keep in mind, -2 is less than 0. So we need have to change this one into greater or equal, right? So here we change to x greater or equal -5. That's it. See? No big change, right? So if you learn this kind of step by step, I don't believe it's so challenging for you guys, right? All right, let's see. See this one. The same here. When we do greater or equal, so distribute inside became 10 and minus 2x. Right, so both sides Right now we go back here, say plus 2x. So this one will become 0, right? Plus 2x, plus 2x. And minus 2, right? Make this 0, minus 2. So this one is not 0. I just say combine here. So here change into what? Is negative 4x, right? Greater or equal became 8. So both sides right now, we again divide negative 4, divide negative 4, divide negative 4. You know, negative 4 is a less number, so we change this one less than or equal. So it will be changed into x less than or equal negative 2. Right? Super easy, super easy. So if you write interval notations, we can see negative infinity to negative 2 to include, right? Include, like this. Right? It's easy. It's easy. Did you guys homework is still the same as what I'm doing?
Yes.
All right. Very good. All right. Let's go 20. Let me jump. All right. I need to go 25 now. I need to jump because they are so close to each other. I don't like to repeat all the same again and again. Okay. Go this one. Okay. So this one is means right now we did a little bit further, right? A little bit further. So both sides need to be distributed inside. Distribute inside. Right? And less than or equals, here is 10x minus 20. So right now we switch back to initial, we just do everything same, try to move to combine like terms, right? So both sides minus 10x, so this product can make it become 0. Both sides plus 4, plus 4. Okay. So finally left behind is 2x for the left part, less than or equal negative 16. Both sides divide 2, divide 2. 2 is a positive number, we don't need changing here, right? So x less than equals to negative 8. So it means it's negative infinity to negative 8. I use this one, this word. All right. It's super easy, huh? It's not big challenge here. Okay, let's jump to 27. 27. 27 actually a little bit further. Oh, thank you, Brian. It's not break time yet, right? My kids give me 2 rabbit candy. Why rabbit candy? Did you guys eat this candy? No. Come on, share you guys. Can go. Take a small.
My mom told me she ate it when she was young.
This is a very good one. Actually, I like it, but I cannot eat now. If I eat it, I cannot talk, right? All right. All right, I will eat it during my break. All right, Brian, you go play, all right? Thank you. All right, let's go. Let me move a little bit down, further down here. So I think it's 27 is the similar situation, right? 27. Let me move to 27. 27. So they are same. Right now, we just learn more information as what earlier what we're doing, right? We're doing. So let's see here. So actually they are same. Right now we need to a little bit complicated here is just distribute inside. We need to combine like terms as well, right? So let's see. So 3x plus 6, right? Minus 6 and greater. Don't forget to, don't try to jump, you know. From my earlier experience is some kids, some students like to combine initially whenever we write out. She say, okay, different is 3x. Yeah, so let's begin 0. Don't try to jump. Try to write as what do you think, and then try to do something. All right. something like a distribute inside, you just need to distribute inside. Don't try to jump, all right? So the rest copy down. So you cannot miss some terms. Some people like to jump. I know he very familiar with that process. That's be okay. But not familiar, just try to do a step by step, all right? So here it became 0. We can combine like term here first, right? So here combine it became plus 20. You can do like this. And right now, second step, we move to here, say, okay, we need a plus 2x, right? So make it, and that's it. So you can got a 5x greater, here became 0, right? So it became 20. So right now we can more simplify it. Both sides divide 5, divide 5, divide 5. So divide 5. 5 is a positive number. We don't need to change this alligator mouth. So the rest will be here. So if you write the interval notation, be careful, is greater than 4, it means 4 is the lowest number, right? And positive infinity. That's it. That's it. Okay, so I would jump a little bit for this section because this section is much easier than what we currently talking about, right? Okay, let's see. So I will jump a little bit. I will send out the answers to you a little bit later. You can check with the one with my answers. So I will jump the part what I talked about in the to the 37 here. Now 29 to the 36 is much easier right now. So if you have questions, you can just leave to me. All right, so let's jump to here. 37. So for these cases right now, it consider you can see this coefficient right now is not a whole number, right? So you can consider like a 3 doing 4 greater than 2, right? So both side times what? They are reciprocal. You guys learned reciprocal earlier, right? 4/3. So 4/3. This is a positive number. Alligator mass not changing. So you can see after that one, here became 1. The coefficient became 1, right? Here is time. Here became 8/3. So you can write in interval notation is 8/3. This is left bracket. No, left parenthesis. I'm sorry. Left parenthesis to positive infinity. Right? So the same. Very familiar, very similar process. Same here. So you can both sides 6/5, right? Make 6/5 is a positive number, so at least alligator mass was not changing. You don't have to change this alligator mass, right? So you can say x greater equal to this 48/5, right? So you say negative 48/5. So right now here is including, so we need this change to bracket, right? Left bracket, right? Okay. So for this part, I will skip. They are the same as what we're talking in the last. All right, let's move down here. That's what the topic I will talking this today. So let's talk a little bit more about. Let me pick 1 or 2 here. Let me wait a minute. Let me talk about 1 or 2 from here. Any question is really for you to get the answers? Did you guys get any question? Which one is very challenging to get answers? No? Yes? Anyone? Did you find that some of the question is too challenging to get answers? See? Nope. Korea?
No.
No. We win?
No.
No. Okay. What about you, Wesley?
Nothing. No.
No. Looks like everyone good at this one. That's good. Okay, let's see one more. Let's talk two more and then we'll take a break, okay? All right, let's see this one. Let me pick 45 and 47. All right, I think it's kind of relatively easy here. Okay, let's see this one first. So first, the same thing needed to distribute inside, right? Distribute inside. Here the same needed to be distributed inside. So you can see here is negative 2x plus 8 minus 3x for the left part, right? Right part. Right part is negative 4x minus 4 plus 2x.
Hello.
So you can combine like terms first. Like this one is like terms. So you can make negative 5x plus 8, right? What about right part? Like terms is this two, right? Minus 2x. So you can see back to the earlier situation. All right. So right now is we combine like term from left side to right side, right? So plus 2x plus 2x plus the same number, not only plus the same number, we can plus the two terms. Yeah, it doesn't change these kinds of alligator mouse, right? And minus 8. So you can see this part became 0 and this part became 0, right? So here became negative 3x less than negative 12. So right now we both sides divide negative 3. So since this one is negative numbers, we change the alligator mouse. So here became, so that's it. See, the step by step, we can use the distribute methods, we combine like terms, and then divide a negative number, so you can get this one, right? Let's go back to this one before we take a break, all right? So this is the same, minus 2x, all right, so 6 minus 6. So you can see what you got. So it became what? Here became 0, here became 0. So you can see it's negative 5x equal than 0, right? So both sides divide negative 5. Divide negative 5. These alligator mouse need to be changed back. Opposite. So you can see x less than or equal 0. So actually this one is got what? So you need to use this one, negative infinity is left parenthesis, right? 0. So did your answer is the same as what I did?
I think so.
Good. Okay. Right now it's 3:36. Let's take a 5 minutes break, 3:41, and then come back. We'll learn a new section about the compound inequality. All right. All right, 5 minutes break, and then we come back. Homework one, I will send out the answers.
5 minutes break.
You check a little bit later together, all right? Okay. Take a 5 minute break, come back for 3:41, not 4:41, 3:41.
哎，林老师你好。
哎，你好。
哎，我是 Jim 的。
So, everyone have back already? So I begin the second part. So the homework part, the rest section actually is compound inequality. I give you this homework. Actually, I didn't teach this part. I think maybe most of people maybe have learned it, but it's okay. Just let you try, all right? So the homework of this part from 51 to 64 is actually compound equality. Actually, that's today's topic. I didn't teach last week. I was supposed to teach last week, but the time is too short, right? So let's begin. Let's continue on this one right here. All right. So we focus on the compound inequality this time, right? Let me show I was, yeah. So compound equality, all right. Compound equality actually right now you can see currently what are we learning say something, what are we learning say -4, greater 4, less than 4. We only say have the left part and right part, right? So you can do the combine like terms or do left side, right side, do proper operation. Say +4, +4, you can get result like this, right? So you can get less than 8 and you right now divide -1, you change to alligator mouse to the greater, right? So you can get x greater than -8. So this is only have left and right. So sometimes you can see some results actually have multi-inequality. Say x less than 3 and greater than -1, right? So in this situation, actually, right now here you can see have the 2 inequality situation. We call this actually called compound inequality, right? So right now I would define here, say, here is the left, here is the middle, and the right, right? So they have the left part, middle part, and right part. Actually, this one is actually combined situation. Say you have find a number, this number less than 3, right? At the same time, this number greater than -1, right? This situation, this is a combined situation. Combined situation. So you say x less than 3, x less than 3. When you say graphing, x less than 3 is less positive infinity, negative infinity, less than 3, 1, 2, 3. All right. So less than 3 is like this, right? And x greater than -1. It's the same time x than -1. All right. So they have overlap area, right? This overlap area. So we say x less than 3, here 3 greater than -1. So when we do graphing with exactly like this one, we only graph this part, right? -1, 2, 3, we only need to graph this one. Actually, so this part is what we want, this part is not what we want. We're only in the middle part, right? The middle part. So when we write the interval notations, we only say 3 and -1, and we're not including these two endpoints, right? So we use the parentheses. We use the parentheses. This one use the comma in between. So this is the interval notation. This is graphing, and this is algebra expression, right? So that's these kinds of called combined situation. So when we made this situation, how we do them? Let me give one example here. Say like this one, just like our homework, 55, actually 55. So you can see this situation. You have the left, middle, and right. How we do this one? We do this one. We exactly use the same methods as earlier. What are we doing? So right now we say we try to make coefficient of the unknown thing became to 1, right? So we have to divide 3. Or left, middle, and right do the same progress, right? Same progress. Divide 3, divide 3, divide 3. So you can get x less than 2, right? Here greater than -1. So we could answer solutions, right? So when we do graphing, this is positive infinity, negative infinity, and 0, and 1, 2. This is 2, right? And -1 right here. So greater than -1, less than 2, right? So we just need to do like this. And interval notation, we just need 2, 1, and -1. Actually use the parentheses, right? We are not including. So there's no big difference, right? We just needed to do left, middle, and right 3 parts together. And the progress is exactly the same as what are we doing. All right, so I will bring this example here as well. Say -1 less than 2x. So if this one a little bit extended situation, look. So the progress will be the same. Firstly, we do +3, right? We make this part became 0, +3. So left, middle, and right do the exact same progress. So will be changed into what? Its middle part will be changed to 2x, right? Here became 8, right became 8, left became 2, right? And let's continue, move on. So we want to make a coefficient of x became 1, we need to divide 2. 2 is a positive number. 2 is a positive number. We don't need to change the alligator mouth, right? All left, middle, and right are divided 2. So you can get x, here 4, here 1. So you got the answers, right? So when you graphing, 0, 1, 2, 3, 4, 1, 4. So both not including, right? So in between these two, that's it. That's it. So when we write interval notation, we just need 1 and 4. Make sure 1 is the small one, right? So often the left number is small one, right number is the bigger one, right? That's it. So we can get this one very quickly out of here. Right? All right, so let's see more example here. Let me bring this up. Say 3 less than 3x over 2 plus 4 less than or equal 5. All right. So what do we need to do the same? So we still do left, middle, and right, 3 parts, right? Right now is -4, -4, -4. Okay, we just make each time that's left, middle, and right do the same thing. Okay, so here is make it 0. So right now it became 3x over 2 less than, here it became 1, right? Greater or equal -1. So this one right now need to make the coefficient became 1. We needed to time a reciprocal number. So it's 2 over 3. This is a positive number, right? So alligator is mouth was not changing. So we still go back here, go back to see to do the proper calculation. So you can see here. So here became x, right? So alligator mass was not changing. Here became 2 over 3. Here became -2 over 3. So it means when we do the graphing, here is positive infinity, here is negative infinity, and this 0. This is the graphing. Basically, we need to graphing this part. Right? So here's 1, all right? Here's -1. So 2 over 3 is about here. So including here, right? And -2 over 3 is right here. So including, we use the black fill dot. Right, so in between these two. Okay, that's it. So when we do the interval notation, so we can 2 over 3, here is negative, including, we use the bracket, right? It's the including is a bracket. So that's it. So we got these answers, right? Okay, any questions to this part? Oh, too quiet. This class is too quiet. Someone make some noise, please.
No.
Noise.
Noise, need noise. Do you see, watch the,
I will not make noise.
do you see the basketball team or NBA and someone take a flag to running around the court, say, noise, we need noise. Too quiet, making me not so active to talk in the class, all right? All right, let's see this one. More example, okay? So -2 less than 3x plus 1 less than 7. So same here, all right? So same, right? Left, middle, and right. And right now -1, make this constant disappear, right? So change to 6, -3. And divide 3 at the same time, right? So here became 2, here became -1. So if you practice this one, if you do homework, I thought a lot of people do this part homework maybe already. This unit, so not so unit 1, 2, okay. So here is not including -1, is right here, in between these two, right? So you can say 2, -1, comma, not including, we use the parentheses. That's it, right? I talk pretty quick actually. Hopefully you guys can make it, All right, so let's go to next step. All right. Did you guys make a notes? All right, so when we talked about inequality, right now we talk compound inequality. So sometimes we can see when these kinds of inequality containing absolute value also have some fraction we call rational expression. Actually, here's a rational expression. Rational expression similarly like this one have the denominators, or something like this one in the denominators. Actually, this one will be described like this. Have these kinds of situation, how we get solutions? Let's see this one. All right. So x absolute value less than 1 right now in this station. Here, so firstly, we need to find out this absolute value less than 1. We know this, we talked about this a little bit. So definitely this is a positive number because of any number absolute value should be greater or equal than 0, right? So we can say this greater or equal 0, right? Because of this one, definitely greater than equal 0. So we suppose this number is a positive number. We just give the first condition. Say when x greater or equal 0. All right, we give a condition. This is condition. All right, so condition 1. Of course, x may be less than 0. So let's combine two possible conditions. First condition is here. So when x greater than 0, we can get rid of this absolute value, right? So it will be changed into less than 1 and greater or equal than 1, right? So x greater than 0 condition in this situation we can get here, right? So it's great. So when we do graphing, we can find out. So 1, let's say 1 is right here. So he's including this dot, not including this dot. It's in between these two. in this area. When this is first station, what about when x less than 0? X less than 0, when we get rid of this one, so it's became the opposite, right? When x less than 0 is a negative number. Negative number absolute value became what? They are opposite. So negative x, right? Right now say less than 1, greater or equal 0, right? So we transform into this situation. So both of, I mean not both, it's triple, left, middle, and right. All divide -1, -1, -1. So this is -1 is a negative number. We need to change alligator mouse, right? All right, so what does this transfer into? Transfer into what? Transfer into x, right? The middle is x. It's greater than -1, less than or equal 0. All right, so it means what? So it means -1, x greater than -1, and less than or equal 0 is right here. Right here, right? So it should be this part. So combine these two. So any numbers, you can pick any number. If there are any numbers in between these two, I mean, between -infinity and +infinity, they possibly have these solutions. So combine these two, we say x less than 1, greater than -1. So you can guess, say, if any numbers absolute value less than 1, you can transfer here, right? If let's say someone asks you, say x less than a, well, I give any number, and a is a positive number. So you can say x less than a greater than -a, right? You can transfer this one. That's why I summarize this small kinds of group here. Say, when absolute value, when x is greater or than 1, can get itself. When x equals 0, get 0. When x is a negative number, they become their opposite. So all kinds of absolute value can be changed into like this. Okay. So let's see some examples. See this example first. Say, let's see this example. Say x minus 3 equals 0. We do this kinds of equation before, right? In the last, week before last week class. So we consider this one as one thing first. So this one will be both sides plus 3, right? We can move the 3 to the right. So you can say, we can know this part can be +3, right? Or -3, or -3, right? Earlier, do we talk like this one? So x can be equal both sides +2, 5, right? Or -1, right? We have two answers earlier. What are we talking about? So right now with this one switched, say x minus 2 minus 3 greater than 0. What can we do? So we do the same progress. We're going to consider this one, both sides +3, all right? Both sides +3. So you can get greater than 3, right? So right now with situation, we go back to this one. Let me rewrite this one here. When x is absolutely greater than a, we can get the two situations is x greater than a or x less than -a, right? That's two situations. What do we do this situation? We do this, we see this one. Have two list situation. One, when x absolute value less than a is in between these two. When x greater than a is outside part of this area, right? So you guys, I don't know you guys list this one or not. Let me explain this one a little bit more. Of course, A need to be a positive number, all right? A is positive number. So let me explain this one a little bit more. So A absolute X greater than A before we talk about this one. So A is a positive number. So when A is greater than 0, when A greater than 0, it means A is a positive number inside. And we can get the absolute value outside, right? Absolute of, because a positive number, absolute value is itself. So it means X is greater than A. So A need a positive number at the same time A should be greater than A. So we can graph in here. Sometimes not easy, we're understanding one step. So we say A at X number is at least in this side, right? And at the same time, suppose A is right here. At the same time, A should be greater than here. So we only use the overlap area. What's the overlap area of this part? Only this part, right? This part is the area. So this part is X greater than A area, right? When X is a negative number, when we say X is a negative number, less than 0. So when we get rid of the absolute value, it will be changed their opposite. Opposite will be negative X. X is a negative number. You put a negative in front, so it became positive, right? So greater than A. And right now, both sides minus 1, not minus 1, divide negative 1, divide negative 1. Divide negative 1 means we need to change this alligator mouse back, right? Opposite to the opposite to be less than. So left part became X less than negative A. That's what I say. It has two parts here, right? X greater than A or X less than negative A. Less than A. Okay, so go back to these examples. Let me do this one. So this one can be switched what? So can be switched X minus, let me go back a little bit. So X minus 2 should be greater than 3, or X minus 2 should be, right now we get rid of absolute, get rid of absolute, right? Or less than negative 3, right? So here change it to, we can get rid of that one. We can erase this part off. Let me make up that one here. Minus 2 should be greater than or minus 2 less than here, right? Less than here, right? Is it correct? So what? So both sides. So this one transform into X greater than 5, right? And what about this one? X1, X less than, both sides plus 2, negative 1. So I have two answers for this equation. Two answers. X can be greater than 5 or X less than negative 1. That's two parts. So when we do graphing, negative infinity and positive infinity, 0. So 5, 1, 2, 3, 4, 5. 5 is right here, too far away here. Greater than 5 should be this part, right? Or less than negative 1. Negative 1 should be right this part. So they have two different parts. So when we do this one, how to write interval notation? That will be easy. We write this one separately, right? Negative infinity to negative 1. And right now we use this kinds of syllables. We use this signal, U. This one called combine. And right part is 5 to positive infinity, right? In these two areas. Okay, so what answers for this one will be got here. Okay. All right. Let me save this one as a picture in case you guys like to know a little bit better. So let's move on a little bit more for the second examples. Second examples. So this one, the similar things have containing these kinds of absolute, right? So we, like earlier, like what we say, we consider this is a whole number first. So this one was be changed into less than 3, right? Or greater than -3. When the less situation, we change this one. When the greater situation, a different one. So what can we do this one now? We use the similar progress. We time 3 first. Why? We make this denominator disappear, right? Time 3. So the left, middle, and right all do the same progress. So here it became 1. So the middle part change into here, right? 9. Here became -9. Right now we get a better idea what's going on here, right? So we go back to the compound kinds of inequality, have left, middle, right. So we do the same progress. So here change into -2x. Here is 14. Here is -4. And right now we needed to divide -2, divide -2, divide -2, left, middle, and right. 3 fractions do the same progress. Keep in mind, -2 is a negative number. We need to switch alligator mouth. Okay. So right now we became +2, right? Greater, here became x, greater than -7. So of course you can rewrite. You can rewrite here. Say we rewrite. We switch here. Less than 2, greater than -7. We can rewrite. It's the same progress, right? This is just rewrite. Actually, this is the final. We can rewrite like this. So when you do the graphing, -infinity, +infinity, and 0. So less 2 was supposed here, -7 was supposed here. So it's in between these two, right? So that's the answer. So if you're not confident enough to say this one is the solution or not, let's pick a special number in between these two to check it. Let's pick 0, right? So pick 0 to replace the x and then try to see what's going on. Okay, so x was replaced by 0. Right now we can see the rest of the inside the absolute would be changed into what? -5/3, right? So this is became what? 5/3, right? Negative number absolute became positive number. This number is definitely less than 3. It makes sense. So I believe this area at least 0 is makes sense. So the rest will be more reasonable. All right. So let's move on another one. So have anyone have question to this part? To these examples?
I don't have any questions.
Good. Response is relatively quicker than what I thought. That's great. All right, let's see next one. See examples of this one. This one right now is a little bit different than what we saw, right? So this absolute x actually is so this one is in the denominator part, and definitely x cannot equal 0, right? Because of the denominator. And if let x equals 0, and denominator would become 0, it will be meaningless. So at least x cannot equal 0. So keep this in mind. Okay, so right now what we need to do is, we know absolute x is, we consider this a unit. So this absolute x is a positive number, right? Doesn't matter what x you are, except 0. absolute value, so became a positive number except 0, right? Definitely take like 0 out of here first. So absolute x is a positive number. Is a positive number. What we can do right now is we can both sides times positive this part. All right. So you can consider this is a number, this is a positive number, and this is positive number. Both sides times a positive number, alligator mouse was not changing. So we can switch into what? Like this. Again, we divide 5 now. Divide 5 now. 5 is a positive number, this alligator mouse not changing. So we can change into what? Absolute value less than 1/5, right? Let me rewrite here. Put this one is less than 1/5. That would be super easy. Hey, do you see that? So x less than 1/5 greater than -1/5. So if you want interval notations, would be, let's see, right? That's relatively easy. So if you not confident, let's pick a special number. Of course, is we forgot something. Do we forgot something? We say x cannot equal 0. Did this part equal 0? Yes. Yes. We need to take 0 out of here, right? So this is not a final answer. Actually, we need to combine this one. So that's why we need a graphing. So let's go back to write graphing like here. Negative infinity, positive infinity, and 0. 0, we need to take it out. It's not belongs to here. And 1/5, -1/5. And between these two, we need to take this out. So we need to take this number should be in between these two, except the middle one. So here we need to write here like this. Here is the left part, right parenthesis, and just like say this is signal we use to describe it is use the and or combine 0 to 1/5. Right. So let's pick one number. We pick to check if they are correct or not. Let's pick 1/6. Can we pick a 1/6? 1/6 is less than 1/5, right? Let's pick 1/6. 1/6, let's replace here. Okay, so 1 divided 1/6 absolute. This one change into 1/6. 1 divided 1/6 equals 6, right? Is this one greater than 5? Yes, it makes sense, right? So the result is makes sense. So be careful about this one. 0 was taken out because of when the denominators, x cannot be equal 0, right? When we talked about the fractions, yeah, any fractions a over b, b cannot equal 0, right? Keep this in mind. So in any fractions, any denominator cannot be equal 0. Okay, I know these times go so quickly. Let's go this one right now. Oh. Do we want to talk about linear line? I think we left the linear line for next week, all right? We can do some basic introduction this part, okay. Just quick introduction of this part, all right? So inequality for this part, there's a lot of things need to talk about, actually. So I will send out homework to let you guys practice more. All right, let's see this one. Before I talk this new topic about linear line, we all talked about only one variables, right? We talked about one variables, x. We only talk one x, what's going on? x. We're talking about ax, right? Ax plus b, maybe divide c. And we're talking about how to build their equation, their inequality. But now we will be talking about two word variable. This is only one word variable. One variable. So right now we will be introducing two word variables. It's okay. It's not big changing. Okay. Now let's talk about the quick examples. Suppose today you guys maybe take go outside shopping together with your parents or mom or dad outside. When sometimes go to shopping, buy some gas oil. You can see outside right now the gas oil price is about $2 per gallon, right? $2 per gallon. Oil price, right? So each time, how much money you paid? Your mom and dad use the credit card, pay the money, right? So suppose say, this is $2 per gallon. So suppose you say, this is the gallon you will add it, all right? This is the money you will pay. So if you add 1 gallon, you pay $2. If you pay 2 gallon, you fill your car with the 2 gallon oil, you pay $4. Pay 3 gallon, you gotta pay $6. You pay 4 gallon, you pay $8. You see these kinds of serious numbers. So you can make these kinds of serial number into like this. 1, and if you pay made 1 gallon, you pay $2, right? Make 2 gallons, you could pay $4. You make 3 gallon, you fill 3 gallon, you pay $6. You can make like this. 4 gallon, $8. So you can see if you make, let me make this bigger. Okay, so this one you get 1 gallon, you get pay $2. Just like you pay buy 1 gallon oil and you pay $2. So Y means the money you pay. X means how much gallon you add, right? How much money you pay. So you can see you pay 2 gallon, you can pay $4. You get 3, maybe got it here, it's $6. 3 gallon, you got $6. 4 gallon, you got $8 here, maybe 8 is right here. And 4 is right here. If you paid 5, you need to pay $10. All right, $10. That's all. So you can see if you link this line together, it's interesting, right? So interesting. This line is a linear line. Linear line. This is where linear line come from. We call linear line. Linear line. This is called straight line. You also call straightforward line. There's no bending, right? So you can see, you can guess in. Someone say 100 gallon. I fill 100 gallon. So you have to pay $200. Yeah, you can just give you any numbers in between right here. Here it goes to the positive infinity, and this end go negative infinity, right? So earlier we just linear graphing only from 1D. This is one from left to right. Right now we've extended to 2D. So if you pick any numbers, you can say fill 50 gallon, you pay how much? You can see maybe fine. You pay $100, you 50 gallon. So this is build kinds of relationship. Use your friend. You can use the table to build a relationship. How much oil you add and how much money you pay, and build these kinds of relationship. You can use also graphing methods. This method actually right now we call it rectangular coordinated system. This each dot. Earlier we talked dot just one number, right? But now we're introducing coordinated system like 1, 2. This is 2, 4, and this is 3, 6, right? And you paid 4, 8. We call coordinated system, rectangular coordinated system. And this each dot right now is not one number right now. Each dot became one pair number. middle two numbers, something like here, this dot. Right now, earlier we say just 3. Right now we say 3, 0. All right, 3, 0, because of there's y part is 0, relative x is 3. So each dot, they actually have pairs of number to compare of. Okay, so we're introducing rectangular system, rectangular coordinate system. So we will talk about a little bit later about, say, this line. Sometimes you can say, if the gas oil right now, we change you only $1 per gallon. So you can make a table. You can see it like this. You can buy $5, only pay 5 gallon, you only need to pay $5. If for 4 gallon, you only need to pay $4, right? If you say the price is increased to $3, they will be switched to like this. Because you need to pay for 1 gallon, you need to pay $3. If you buy 2 gallon, you got $6, right? So it'll be switched. So your linear line is this one becomes angle, the slope is more bigger and bigger, right? So we will talk about the slope. We will talk about next week, okay? It talks about slope next week. So let's stop here for this week. All right. Thank you, everyone. So have any question to this part, you can let your parents to send me note, and I record this part actually. I can put some limited access to only let our class.
I think you can just send us the link to the note to print.
Huh? Oh yes, you can note to print, and I record this part, so I will put someone else, someone really need to and to see this part.